are going to be using the Python programming. We're going to be using Python programming. So very quickly in the chat room, let me also hear what did you learn yesterday? What was the key takeaway from yesterday's class? What was the key takeaway? I want to see our comments in the chat. What did you learn that you've not learned before? Oh, Precious is saying today reduce the speed for those who have no background. So the session recording is always available on our TSN YouTube channel. I mean, this session is always recorded and we're also streaming live to our YouTube, which means that once the session ends here, you can always fall back on the recording on the TSN YouTube channel. Oh, Hamed Abubakar, thank you. Ahmed said variables and conditional statement. Variables and conditional statement. So we learned variables and conditional statement. That's spot on. That's spot on. Yeah, so this is 11:09. I think this is a very good time to start. Alima said, I've been learning it before, but it made it simple. Exactly, exactly. You all agree with me that this is it. I mean, this is it. Yes, we made it simple. I agree with you 100%, and that is why we've created this platform because it can actually be difficult sometimes when you are learning a novel, but when you see someone to guide you, it makes it very easy. And that is also the reason why you need to also invite your friends to join this class. I mean, don't keep the knowledge to yourself alone. This is a platform for everybody to learn. So if you have somebody you feel will be interested in learning, reach out to them, share the Zoom meeting link with them, let them join to also have the experience you are having. And also believe that you want to share your learning experience. So in one of the sessions, we are going to be releasing all the tags that you can put in your social media posts. Yeah, we're going to be releasing that. And then my colleague Chidima, as usual, will drop in the attendance link and the link to the Telegram group at intervals so that the class is not disrupted. I could see in the chat yesterday, someone was actually saying it is very important to get the knowledge instead of people asking for attendance, link, which was very right. I mean, which was very correct. It's very important that you listen in class. That is why we're here. But it's also important that you fill the attendance link. So my colleague will be dropping the attendance link at intervals. So just keep following Chidima. Just keep following her updates in the chat. She's going to be dropping the attendance link, but make sure that it's not distracting you to learn. Yeah, thank you so much, everyone. Yeah, I think this is a very good time to pass the mic to my wonderful colleague, Mr. Iwezu, who will be taking us on the journey again to put us through. So there are other things that we need to learn on Python programming before we move to the machine learning and data science proper. And that's what is going to be taking us on today. Thank you so much, everyone, for joining. And I wish us a great learning experience. Over to you, Mr. Iwezu. Please confirm you can hear us. Okay, so I think our facilitator is finding it a bit hard to unmute himself. Yeah, this will be Mr. Iwezu, you should be able to unmute yourself now.
Morning, everyone. Can anyone hear me? Good morning, everyone. Can everyone hear me? All right, good. I hope you guys had a good night's rest and learned a lot from yesterday. All right, so today we'll be beginning with Python data structures. Python data structures. Right. So let me check. All right. So I have to believe that you all can see my screen. All right. Good. All right. Lovely. So, has anyone heard of the term data structure before? Does anyone have an idea? Anyone? Before I go into talking about data structures. All right. So, yeah, good, good. Someone said list tuples and dictionaries. Those are examples of them. But can someone tell me like what a data structure is used for? Like, what idea do you have about the data structure is? I really like to hear what your ideas and whatnot. Tao, I think it might be from your end. Yeah, exactly. Someone said sorting information in organized form. Yes, that's very good. Python data structures are used to store information in an organized form. And we have three main types. We have lists, we have tuples, actually we have four main types. We have lists, we have tuples, we have sets, and we have dictionaries. So let me begin with a list. Begin with a list. So to create creating a list, creating all these data structures, it's not that much different from creating a variable, but there are some differences. So what you do really is you give your data structure a name. So here we're creating a list. Let me just call it L1. We're creating a list. So like you create a variable, but then the difference here comes with you then put the values in square brackets. Yeah. So your list could contain different types of data. It could contain integers, could contain floats, could contain strings, could contain multiple data types in one. You can have multiple data types in one string. So yeah, all right, one list. So this is a list of numbers ranging from one to four. We call the L1. When we print our list, it gives us our data in the exact in the order in which we typed it. In the order in which we typed it, we have our list. Some other data. Yeah, let me see my screen. The good thing with list is that we can put different data types in a particular list in them. But with certain other data types, that might not necessarily be the case. So here I'll put a number with a string and I'll print. And then here we have a list comprising of a string and int. And let me create another list comprising a string, an int, and a float. And here exactly we have another list containing a string, an int, and a float. And if we were to find the type of this element L3, you'll see that um its type is a list. So L3 is recognized as a list by Python. This is how you declare lists in Python. Now, the cool thing with lists and data structures in general really is that there are ways of accessing specific elements in them. So instead of printing out the whole list, if you have a specific element in mind, you can access it through something called indexing. I hope thus far all on the same page. So I'll do an example of indexing. So let's say we want to access the first element in our list L1. We simply write the list name and beside it put square brackets and the index we want to access. And then boom, we have been able to access one, which is the first element. in our list. Note that I use the index 0, and that is because in computing generally, and more specifically data structures, when we have things ordered in anything, the first position is always regarded as 0. We don't start from 1 but 0. So that's why the index is 0. I hope that's understood. So yeah, we could access, the other ones to access one, refer first and second element, which have an index of 1. We will access the third element, which have an index of 2, and we'll access, okay, sorry, I put L2 rather, L1, yeah, index of 2. And obviously, our fourth element would have an index of 3, so that's how it is. So now, be mindful that when dealing with lists, it's important that you know the length of your list so that you do not try to access elements that don't exist. And what do I mean by that? Okay, fine. So let's say we try to access an element in position 4. You get an index error. Why? Because this list only comprises of 4 elements, which means that the last index is index 3. So an index of 4 is out of range. So when you try to access your list, you should be mindful of how many elements you have in your list to avoid getting these errors. Now, another cool thing with list is that you are able to access more than one element at a time. So, access, and this is called slicing. So let's say we want to access from 0 to 1. Exactly. So we got our first two elements. If you notice with my slice, I put from index 0 to 2, the let's call it the let's call it the upper bound. It's exclusive, really. It's not involved in the range. So what I mean is that when you index like this, our list starts from 0, then goes to the next one and ignores 2. 2 is ignored essentially. So it only gets the element position 0 and a position 1. So this is how you slice your list. Yeah, so if you wanted to, yeah, so you get everything except from the last one. We simply do this and we have all the elements apart from 4. Yeah. So another interesting thing is that if you do not know, let's say if for example, for whatever reason, you do not know the index of the last element, so just and yeah, maybe yeah, probably because maybe you don't know the length of the list or whatever. To access it, you could use the index minus 1. And why does this work? I mean, think of it this way. So let me just display our initial list. We had 1, 2, 3, 4. Index 0, index 1, index 2, index 3. If you were to move from 0 to the left, you're going to get, you're going to arrive here. You're going to arrive at 4. And, mathematics know that after 0, negative axis, you have minus 1. So to access the last element of a list when you don't know, if for example, you don't know the length of a list or whatever, so you could use the index minus 1 to access the last element. So yeah. Another cool thing with lists is that when you create them, you can edit them. So after creating a list, you can always add more elements. So we know that our list ended at the index 3. I could create another element. Okay, wait. Okay, sorry. Yeah, okay. That doesn't work. Yeah, it's append. We use the append function. Yeah. Yeah. So we use the append function to add another element to our list. So that's the cool thing about lists. When you create them, you can still edit them and stuff, you know. Yeah. So we can append to our list. We can also remove really. So say we want to remove particular elements. Uh, yeah, so now includes and boom, we've removed the element one. You know, so these are some really cool functions with lists, and they go on and on and on and on really. There are a couple of other ones. There's another one called extend. If so as you've seen, we also have another element to extend. So let's say we have two different lists and we want to make them into one list. We can use the extend function. So now this is a list containing only one element, six. We can use the extend function to make this list an L1, one list. If we were to use append, what we'd have would be different, and you would see that. So if I were to use L1 to append, let's now you can see that when we use append to try to join two lists, what we end up having is that we have the broader list, like which is our original list. And then we now have an element that is a list, you know. So we can see elements two, three, four, five, six. And then the last element is also a list. So this also shows you that like, yeah, this the utility of extend. It can be used to just quickly like to join two lists, you know, nicely. With append, we end up having what we call a nested list. So in our list, we will have another list inside this, you know. So yeah, that's what the extend function does, and that's what it has over the append function. Uh, So now let's move on to tuples. Okay, so does anyone have any questions? Does anyone have any questions? Sure, listen, it's yours for this now, freestyle. Um, okay, okay. Let me explain extend. So you know I told you earlier that we can use the append function to join or to add an element to our list. So we had our list L1, which comprises of numbers 1 to 4. And when I decided to append a list to it because I wanted to join these two lists. But instead, what happened with append? What happens with append is that what append does is it just adds what you put in this. It passes. It just puts the argument you pass through it. It just puts that into the original list. So now, when we use append with just like regular elements, it puts those elements in the list. When we use append on lists, as we did here, it puts that list in our initial list. So we end up having a nested list, which is basically a list that contains another list. You know, we have elements two, three, four, five, six. And then these square brackets around the seven show that that seven is a list in its own right. So we end up having a nested list. But with extend, what happens is that it's just it joins these two lists really, as I showed earlier. So with this, when we wanted to join a list comprising of only element six to our L1. extend, joined those lists together into a singular list, or with append would have had a nested list. So I hope that is clear. All right, so some other pretty cool list functions. I think there should be one called delete. Let me see. Okay, no, let's do delete. The other really cool list functions, and let me see. Yeah. There's so many that you can't remember every single one of them. As long as you might have to even search them or whenever you want to use them. All right. So let's see. So you've covered append, you've covered remove, you've covered extend. Okay. So let me cover method called clear. So let's say we've created our list and for some reason we want to remove all the contents in it. We use clear and then clear gives you an empty list. So our list is now an empty list. So that's what clear does. And another really cool one is index actually because it's really interesting how, to access elements, we use their index. But this is also a way of finding the index by using the elements. So let's put in any one of our elements. Let's put in two. Oh, okay, have I removed? Okay, yeah, L1 is now an empty list. So yeah, let me use around all this. We have L2, L2. Suppose L1 is an empty list, so we're getting this error, because there's nothing in L1 now. It has a length of zero because it's an empty list. So as you can see, zero because it's an empty list. So let's use L2. Yeah, and so the element two in L2 is in the third position, so it has the index of two. So that's how index works. Yeah. So another really cool one that I like a lot is dictionary. And like its name is really like intuitive. Why? So you know how we use a dictionary to be able to find the meaning of words. This is sort of like goes by the same a similar concept. So instead of using square brackets, we use curly braces. And in dictionaries, we have what we call key value pairs. you know. So just like how in a real dictionary we have the words and their meanings, you have key value pairs here, where the values are associated with a particular key. Right. So let's create um, a dictionary containing, names of students and their scores in an exam or something. Yeah. So pretty right. So yeah, this is a dictionary. This is our dictionary, and so this is a dictionary containing the names of students and their scores. So to be able to access the scores or the values, we pass in the key. So through the key, we get the values. We use the keys of our dictionary to get the values. Yeah, so that's essentially what a dictionary is and how dictionary works. Um, yeah, so so dictionaries and lists really cool, really good ways of storing the information, and we can also when we get into looping, you could see how you get to learn about how you can iterate through them, you know. So that'll be there anyways. Let's see if we can access the values to multiple keys at the same time. Okay, no, that doesn't. Okay, yeah, that's interesting. All right. So let's say we have a dictionary and we don't know the keys, whatever it is. So with the keys function, we can see all the keys in our dictionary. Yeah. And so let's see. Yeah, it's an argument. Yeah. Okay. So with keys, we can access all the methods in our dictionary or all the keys in our dictionaries, the future the things that we use to access our values. Yeah. So this is one of the really cool methods that the dictionary data structure gives us. So yeah, there are probably a few more meetings. So let's see. So here, here. So yeah, I'm just take a couple and yeah. So where is my initial? I think it's here. All right. So let's say for whatever reason we want to store the values of this dictionary somewhere else. We can make use of dots of the copy method. So fix the copy. And then boom, our dictionary has been copied and saved in this very report scores. Yeah. So yeah. So with the copy, we can copy our dictionary and store it elsewhere. We also have the pop, which is used to remove key value pairs from our dictionary. So let's see. Let's see. Now with some methods, you have to. Yeah. So you use the scores dot pop. What happens is you use the key, you pass in the key, and then your dictionary is then being edited. So what happens is the key and the value are then removed. They are then removed from your dictionary. This so just like a list with dictionaries, you can remove the value stored in them. You can index them, but unlike lists which use the index positions, which are numbers, to access the elements. With dictionaries, to access our values, we make use of the keys to access our values. So another interesting dictionary method is example. Because I tried values before and it didn't work. So let's look at let's see some. Sorry, I think that was a mistake. I tried values before and it did not work. Let's see what did I put value. Okay, that's why it worked before. I think I probably use singular value or something. Yeah. So just like we can access our keys, yeah, its values, not simple. I think that's what I used before. Not like we can access our keys using the keys method. Can also access our values, using the values method. Yeah. So that's that. And I believe that with dictionaries, let me see something. Okay. Now, with certain data structures, you cannot store different data types within them. And I think the data structure in question mark be a tuple or a set. So yeah, just like a list, you can store different types of data types in a dictionary. So that's pretty much. Let me see something. Yeah. Yeah. Okay. Nice. So now, yeah, another interesting thing is that with dictionaries, not only can we store like data types like ints and strings as our values, we can also store a list in our dictionary. Like, can you imagine that? So yeah, that's really interesting. So as you can see here, by using the key K3 because that's the key, you're able to access this list. And now here, this value happens to also be another dictionary, as you can see with the curly braces. So here we have another dictionary with the key inside key, and its values are a list comprising of numerical elements. And one of its elements is also a dictionary. Like, can you believe that? So yeah, in lists you can store dictionaries. In dictionaries you can store lists and dictionaries as well. So yeah, it's really, really interesting. So let's try to index. So yeah, K1, K2, K3, they're quite straightforward, they're quite simple. So let's try to index the ones in K4. Let's see something. So yeah, with K4. I don't want to know, but yeah, I didn't remember this. Yeah. So K4. So then let's say this is the dictionary in K4. See, we want to access, yeah, and this dictionary has only one key actually, which is inside key. So when we use inside key as our index, inside key as our index, we get access to the values in inside key, which is this list. And then to get access to this one, if we want to get this particular one, this particular list, let's see. There are a couple of ways to go about it, to be honest. Let's try this one. Exactly. Okay, no. This gives us the elements. Yeah, because this whole thing, like this whole dictionary, is the elements in this list. So when we get the last elements, we get this. Yeah. So when we get the last elements, we get this. And to further index, as further index that, so I'll just copy this. And then yeah, we have been able to access the values inside this key. So yeah. So and then we can also go further really to want to slice this. So I'll just copy this. So who can tell me in the chat if I want to be able to get the first two elements, what do I write in here to slice this list? Can someone tell me that? Yeah, exactly. Dictionary is called the nested. It's called a nested dictionary. Yes. Someone asked, at what point do we consider storing in a list or storing in a dictionary? Okay, was that one before you consider storing in a dictionary? I mean, okay, storing a list in a dictionary or dictionary. If you want to store a list in a dictionary, could come in handy where you have a key that probably has like multiple values attached to it. So, like the way we normally initialize dictionaries, it's a single key to a single value. So if you want to put a bunch of values, like we did here, you could put them in a list. If we were to do this without any, there's an error. Exactly. You cannot attach multiple values to a single list or to a single key, as I will to a single key. So in that situation, you will then be able to use a list to help you address that. So I hope I've answered your question. I've gotten to answer that question. Yeah. So I hope I've answered that question. So no one, yeah, okay, fine. Let me see. I'm seeing some answers. I'm seeing some answers, I'm seeing some answers. Okay, some answers are right, some answers. Okay, someone asked me to say a question again. I said, if I want to access the first two elements in this list, what indexes would I put here to slice? What would be the lower and the upper bound? That's why I asked. So I've seen some correct answers and some wrong answers. Let me give some time for you guys to keep giving answers. I said the first two, not just the first. For those of you who are giving me a single index. Okay, some of you are trying. Okay, so let's see. Someone suggested 0, 1. Let's see if that works. No, it doesn't work. And why is that? As I said before, when slicing, the number in red letter is excluded from the range. So in the range of 0 to 1, given how slicing works, 1 is excluded. So only 0 is taken. And as some people suggested to use 0 to 2, which they were correct, that is what helps us get the first two elements because the index 2 is ignored, but 0 and 1 are part of the range. So it gets us the first two elements of that list. So that's how we do that. Yeah. So that's how we do that. Yeah. So that's something I want to try. Another interesting thing is the fact that you don't when you want to start from index 0, you don't necessarily have to write index 0 there. Yeah. As so you could just leave it, just put your colon and then where you want, and then the index you want to be excluded from that range, and then we exclude two, so it starts from 0 to 1. And if you want all elements actually, so you could really just you don't put anything before or after the colon, and then it just gives you everything, Yeah, so there's that as well. Yeah, so those are like two really interesting ways of us accessing the elements here. So also, if I wanted to access the last element, or let's pretend that we don't know what the index is. How would I be able to access the last element in this? So only one person has answered. I need more answers. Are you guys sure? Think very well about it though. Are you sure? All right, good. So yeah, it seems everyone is clear on that. Yeah, -1 is actually the correct answer. So then we use -1 and then boom, we're able to access the last element. Yeah. So let me see. So, so- Now there's another thing. There's another thing. So if I wanted to access this particular value, yeah, how do you guys think I should go? That should be gone now. But if I wanted to access this particular value, so let me just help you with to a particular point. Q4. So yeah, what would I put here? So guys, I'm waiting for your answers. I'm saying zero, I'm saying -1, I'm saying okay. So let's see. So when we do this on its own, what do we get? We get the list. Yeah. And so to access this, you just put in the index and then boom. Yeah, that's how we access the first element. You know, that's how we access this. Yeah. Um, and if you wanted to access this dictionary, how do we do that? This entire dictionary. So I want to access this entire dictionary. That's right. That's not necessary. On set. Set of two. Um, I think I asked a question. I won't ask. Yeah, so I think I muted myself by accident. And I forgot what question the question I even asked you guys. Anyway. What question did I ask you guys again? So, can someone remember the question I asked? Yeah, which starts. Okay, how to access dictionary K4. Okay, that's not what I asked. But then actually very good. Okay, let's see. Like, I don't think that's what they asked. So just anyways, ignoring that. Just let's ignore that. So let's also see something for the sake of saying, right? Let's see. Let me dig the values. What's it give? Let's see. Yeah, it gives every single thing times the list, and then this very big dictionary. Yeah. So that's interesting. That's very interesting. So guys, I know it's easy to get confused because of the several curly braces and different things, but every single thing outside, like after this colon, is the value of key for every single thing. So yeah, don't get too confused with that. All right. So what if you wanted to access the second last element in the K3 key? Does anyone have any ideas? No, I said the second. Oh, yeah, yes, but let's pretend that we don't know what the index is. Let's pretend that we don't know what the index is. So how do you go about it? We know how to access the last one when we don't know what the index is. So what do you think? How do you think the second to the last one would work? Exactly, minus two. So then, yeah, we're able to get the second to the last one. Second to the last one. There. Are there any questions thus far? So I don't really understand your question, Tomini. You said, can you use the run to? I don't get what you're saying. All right. So if there are no questions, how do you get a particular value? If this is a dictionary, in a dictionary to get a value, you use the keys. That's pretty much what I've been explaining all this while. So if you want to get 10, how do you know the key of 10? To the left of 10, you can see a colon. To the left of that colon is this thing in inverted in quotation marks. So K1 is the key for 10. So to get access to 10, you get 10. The another alternative, actually, if you want to get, there's another alternative, or rather, let me experiment on the alternative. So now let me now try. Okay, no, that doesn't think you can't subscribe that. So that was another approach I was trying. Yeah, to see if you could subscribe to this. Let me even see what data type this is really. Yeah. So what data type is dictionary value. So let's just leave that approach. So the general approach, you subscribe the dictionary using the name of the key. Yeah. So that's pretty much it. Okay. Exactly. So and note that your key name should be in quotation marks. it should be quotation marks. Yeah. If not, you'll get an error. So yeah, so I don't let me try some how to try. Let's say create a variable. Can I use that variable as it? Ah, that's interesting. Okay. What will be printed out? Okay, nothing really special happens. Nothing really special happens. Nothing really special happens. So yeah, this is we also do this, but I don't there's really no value in this. See, here we define the variable and use that variable as our key. You know, interestingly, when you do that, the variable's value is not altered at all. It remains the same, but there's really no utility to do it. I don't really see any use for. That's a cool thing for us to know. Yeah, so but yeah, your key is always be in quotation marks when you're creating a dictionary. It could be single, it could be double. Really, so you use double. Yeah. But single, it could be double. But one thing is that you cannot start with single and then end with a double. No, that one automated. The type of quote you start with must be the type of quote you end with. So if you start with single, you end with single. And this goes for strings, generally speaking. And if you start with double, you have to end with a double. So yeah. So that is that. Yeah, you can run the code offline. Yeah, you can run the code offline. So Martin, what exactly don't you understand about the key inside and inside key? Yeah. No, yeah, because there are so many things you talked about with regards to them. And we want to move on to set. So he give you if you clarify your question. Yeah, so any questions? Any questions? Hmm. So someone says they're getting error messages. What are you trying to do? What did you try to do that gave you an error message? Let's quickly address so that everyone is carried along. Okay, so while waiting for that, let me start with sets. All right. So sets, this is another type. This is another type of data type or a data structure. Like we have our list and dictionary. And it's quite similar to a list actually, just that we, initialize sets differently. Yeah. So instead of square brackets, we use curly brackets with sets. If we were to print type A, you have class sets. So now, if sets and lists are very similar, I mean, that's the big differences, yeah. So yeah, there are quite a few differences between sets and lists. The first thing with a set is the fact that you cannot have it deletes duplicates essentially. So let's create another set, and then let's print B afterwards. So you can see that despite us putting several elements in this set, when we printed out the value, it only gave us one element. Why? Because everything here is the same. Now, if this was a list, that won't have been the case. That won't have been the case at all. We would have had all our elements being printed out. Yeah. So that's one of the things with sets. Another thing with sets is that we cannot index them. Yeah. You cannot index a set, unlike lists which you can index. So it's like one of the reasons why I think like most of the time you really ever hear people talk about sets and stuff because okay, fine, you create element, you create it, you store your elements, but you can't store elements that are the same. You can't have duplicates and you can't index them. So which is actually why we use lists more often than sets. Yeah. So there are two ways of creating a set. This is one way, and another way is this way, using the set method. And then to begin to put values in, we then use the add. So here is a set called x, which has a value of 1. So let's see. Sorry. Yeah. And this way, I can only add one element at a time. So let's try to add another one. Let's try to add another one. Use add and not. We have multiple. So with just like how we had the extend to help us join, we can use the extend to join two lists. We can use the extend to add an element to a list, like how we use append also. So with sets, so we have what we call union. I believe we can use union to join two sets. So and what the one first was called? Let me use the one that was called B. So to join two sets, we use union to be the union. Well, yeah. And interestingly, if you remember, our B was all ones, and this X has 1 and 20. So because one, like our B is 1, if you add this, you have 120, and sets do not accept duplicate values, you only have 1 and 20. So that's another cool thing with sets is you can sort of subtract them. That's another really cool thing too. Okay, let me see something. Let me see these. So I think it's a function called difference. It should be a function called difference. So difference. Let's get into this. So there is a way to let me see which one does this. So there are two really cool things with sets. You can be able to find the elements that are not common to them. You can also find elements that are common to them. So there are usually two ways, difference and intersects. But I think I might be using them wrong. So let's just see. Okay, it's intersection, not intersect. Well, yeah, it's intersection. And yeah, so B dot intersection X. Yeah, so this gives us what is common between the two sets, which is one. And then B dot difference. This is quite weird. Let's see something. A dot say that's quite strange. Hmm. So yeah, that's how it's used for whatever reason. Let's see. Okay, so yeah, difference works in an interesting way. So what it does is, okay, fine. When we tell it B difference X, we're telling it to give us elements in B that don't exist in X. And as we know, one exists in B and one exists in X. So that means, yeah, and B only has one element, which is one. So there is no element in B that does not exist in X. That's why it gives us an empty set. However, if we were to do this, we'll get 20. So actually, just copy. So the X difference B, what's actually being done is we're telling it what elements are there in X that don't exist in B. And please give us that. So yeah, B difference X and X difference B give you different answers. Yeah. So I think we've covered, have we covered union? Okay, no, okay, we've covered union. Covered union, we covered intersection, we covered difference. There's one more proof. Okay, I'm seeing a lot of things in the chance. No, you created a tuple object. That's why, not a set. Tuples are created with parentheses. Sets are created with curly brackets along reward. So that's why you're getting the error. Yeah, try. Yeah, it's intersection. Intersect is no. The function is intersection. And as I said, when you try that, it gives you what's in B and what is in X, which is one. Um, yeah, and this is a very good question. So why do you have sets at all? Well, so let's say there's a situation whereby we do not want to have duplicates in our data. So it makes sense to store whatever information we have in a set. So it makes sense to store them in a set. So that's one use case. What else is there? So there's nothing else really. So let's explore that. There's a mutual transaction of what's it's called. So let's see how difference. Hmm. So yeah, we can also remove elements from these sets. And there are two ways of going about it. We have discard and remove. So let's see if they work any different. Let's see if they work any different. So, yes, this is something it doesn't even exist in this. So, this is wrong. Let's remove cards. So let's see. Excellent discard something. This have one. Excellent discard 20. And then it goes. So let's add the back and see how remove is different. X to add 20. X. So yeah, it works same way. Then I wonder why you have two different functions for doing that. So let's read the documentation. This is one really things about like being like programming. Documentation is really important, to help you understand how a certain method works. So let's look at this. So does anything make it different? Oh, interesting. So that is what happened. Oh, so so let's try. So we have, let's say, okay, excellent. Let me match. So that's the difference. Yeah? All right. So now we try x dot discard small dot x. So, and so that's the difference between both of them. When you use discard to try to remove an element, if the element is not present in that set, then nothing happens and you don't get an error. But when you use remove, you get an error. It tells you that that element does not exist in the set. Yeah, so that's the difference between them actually. Yeah. Okay, someone asked what's the difference between dictionaries and sets since they both use curly brackets, and that's a good question. So if you notice, dictionaries store values in pairs. And what I mean is, let's go up. Dictionaries store values in pairs. As you can see, the first thing in this dictionary is a key and a value, a key value pair. They store values in pairs. Sets store elements are like individual. They don't come like the whole concept of a dictionary is to store information about something. So you are storing information about your key in it. Like the concept of how you find the meaning of a word in the book or the dictionary. You find the value of your key in, yeah. So dictionary store values in pairs, set store singular elements. Another thing is the fact that you can actually index your dictionaries. You can get the values in dictionaries by using the key. So as I showed earlier, if you want to know the value as given to this key, you can get it. But with this, but you can't index a set. You can't index a set. You get an error because you can't. Yeah. So that's another difference between both of them. All right. So then let me talk about tuples. So initializing a tuple is done using parentheses. Unlike lists that's done using square brackets and sets that are done using curly brackets, use parentheses instead. I think someone had an error in which they said tuple in the error message. Yeah. So that's how I could tell that that person did not actually create a set based on the error message. Because here it says tuple object. So that person created a tuple but thought they were creating a set, which was why they got this error. Yeah. So if when we try to find the type of I, we see that I is a tuple. Yeah. So let's see. Okay, so before I go further, does anyone have any other question? Yeah, that's true. Let's try to forget actually. There's another way of finding the intersect. You don't have to use intersection. Yeah. So you could simply use, where are you? Yeah. And then it gives you, so it works the same as intersection does, using this symbol and difference as well. I think I tried to use a minus sign before, but I stopped. Yeah. Difference as well, yeah. So difference as well works. So you can use subtraction to do bit or difference, you know, and you can use this symbol to find the intersection between sets. There's also another really interesting one I forgot about that also. So something called the symmetric difference. So what that does is it finds elements that are in either set but are not in both. Okay, so what does that mean? Let's say we have this. Let's say we have a set of odd numbers. Yeah, I'll stop there. And a set of even numbers. Yeah. If we want to find the symmetric difference, this is what we're going to get. Why? Because what it does is, so this is actually even a really cool, this is a cool way of, so in this instance, you'll be able to almost perform a union. You could see that you really just combine both of them. But why that also was because this symmetric difference works by finding elements that are in either sets, but do not belong in both. So, for example, elements 1 in C does not belong in E. Neither does 3, 5, 7, 9, 11. And the same applies for all the elements in E. 2, 4, 6, and 8 don't exist in C. So all are combined into one superset. Yeah. So to make that clear, to make that very clear, let me add an element that exists in both of them to E. Let me add 3, let me add 5, let me add 7. And now you notice that in this new set, 3, 5, and 7 don't exist. Why? Because 3, 5, and 7 belong in both sets. So the simple way to understand symmetric differences, it's the set of it's a set that is made up of elements that are not common, that don't belong to both sets. That's essentially what it is. All the elements that don't belong to both sets are put into a single set. So that's how that works. Okay, so what's happening now? Okay, yeah, I was explaining how we could perform intersection by using a different way. So instead of using the intersection method, you can do it this way. And I also explain how you can do difference by using this instead. Let me even see if you could perform union by using plus. So let's say b plus x. Okay, fine. You can't perform union by using a plus sign. Doesn't work. Doesn't work. So yikes. You have to use union. There's no other option. So that's actually what I was explaining there. So yeah, difference. So someone said the one situation can we use each of data structure? Okay, fine. So as I mentioned earlier, we use dictionaries to store a pair of values. Yeah, a pair of values. We use sets when we don't want duplicates essentially, really, and we don't want anyone to be able to access individual values. We use lists. Let's even see something as well. There's something I want to check. Sorry, I'll come back to that question. So can I add history to this? but one of these data types does not accept. Okay, so that's probably a tuple, then, not a set. Okay. So just like lists, can combine multiple data types. Yeah. So another instance where you use a list is if you want to be able to access your individual elements, if you want to be able to slice them, if you also want to be able to iterate through your data structure, that's something we'll talk about later. So yeah, those are when you use set dictionaries and lists. So as for tuples, yeah, back to tuples. So with managed tuple, we use parentheses. We use parentheses. So I want to try out something. And that for one of these data structures, you cannot combine elements of different types. So let me try to put a string here. Okay, and it still works. Okay, fine. So I guess I was mistaken I guess I was mistaken there. So you can also combine elements of different data types in a tuple. Yeah. So that also works. Any other question? Any other question? Before I go on. So it seems like there's no question. Am I missing anything? No, tuples have to be declared with the brackets. So let's try another thing. Let's try to add a list to our tuple as we explore the differences between all these different data structures. So let's see six, eight, let's see, and then G. All right, yeah. So we can put a list in a tuple. Let me try for this set. Wow, yeah. So interesting. With sets, you cannot store single elements and lists. You can only store, you know, you can't store a list in a set, essentially. What's what I'm trying to say? You can store integers, you can store floats, you can store strings, but you can't store a list in a set. In a tuple, you can store different types of data types. You can also store a list. Let's try out for dictionaries and both of them as well. So and then as well here we can also put in a dictionary in a tuple and with a set, can we? Let's see. Yeah, that doesn't work either. It doesn't work as well. So yeah, in dictionaries you can have other dictionaries inside them, you can have lists inside them. In tuples, you can have lists inside them, you can have regular elements, you can have dictionaries inside them. In sets, you cannot, you can only have how do I call them now? Singular elements. And what I mean by that are integers, floats, strings. You can't have a list, you can't have a dictionary, You know, can we have a tuple in this set? I also doubt that as well. Let's try that. X. Okay, that works. You can have a tuple B. Okay, yeah, yeah, that works. So you can add a tuple to a set, but you can't, yeah, because in this time this tuple is single. So you have to, yeah, you can add a tuple to a set, but you cannot add a list or a what's it called? Or a dictionary. Dictionary. Yeah. So suppose let's see something here. So yeah, we can index our tuples. We can slice them. Okay, so I have a challenge for you guys. If I want every element from the second one to the last, what do I put in my square bracket? Yeah, Hussein, yeah, with your question, yeah, we're going to find out very soon. You see that. So anyone. All right, yeah, so you guys are learning quite well. No, Benga, it's not from the second index. Remember that our indices start from zero, so it's zero, one. So if you want from the second element, you start from one to, to the end. So that's how we get from one to the end, you know. Yeah. So I think let's try to index it. Let's into this one. Yeah, our list is so if I want to get the values in this list, let's say I want to get value 7, how do I go about it? You don't have any ideas? If I want to index our tuple and get a particular value in this list, that value being 7, how do I go about it? Yes. Okay, anyone other answer? Does anyone have any contrary opinion? Anyone? All right, then yes, you're correct. Shedu. That is actually how to go about. I'm getting a contrary opinion. And yes, I guess, well, yeah, bro, I missed for 6. That's how to go about it. Hussein, yes. No, Michael, no. That's not how you go about it. That's not how you go about it. Oh, let me. That's not how you go about it. That's not how. And for dictionary, it's really quite straightforward, honestly. Dictionary is the last element. And if you want the key specific, rather the value specific, it's this. Okay, what can someone tell me what would I do if I want the key instead? I don't want the value, I want the key. If I want the key to this dictionary in this tuple, how do I go about it? So any ideas? Any ideas? Any other suggestion? Any other suggestion? So I assume we all agree to Vesta then, since he's the only one. Alright, so let's see. Yeah, so it's keys, not key, it's keys. And let me even see something. Yeah, that doesn't so it's keys. And then we get it's so that's it. So we're going to move on to loops. We're going to move on to loops. So does anyone have an idea of what a loop is in programming? Does anyone have any idea? Anyone? Okay, so to save time, a loop is basically a loop is, I'll call it a command. Yes, exactly. It's a way of doing something multiple times. And so we have several loops. You have for loops, you have while loops. Yeah. So yeah. So I'll go through for loop. So to use a for loop in Python, there are a couple of ways to go about it actually. So for I in range, once it starts, I want to end. And then put our block of code here. So the whole point of loops is to perform a particular block of code repeatedly. So let's say we want to print this statement multiple times. In this case, twice, really. Yeah. So yeah. And similar to when we slice our lists, when we use for I in range, what happens is that this second number, the upper bound is excluded from the range. So it's 0 and 1. And yeah, so that's why it happens twice. If you want it to happen 3 times. So it's 0, 1, 2, 0, 1, and 2. So this happens 3 times. So that's how this works. There's also another way we could use it. We could actually iterate through a list. That's a cool thing about lists. You can iterate through them to perform our loops. So let's say we have a list containing these values. What the values are is really okay. No, you can't use this is a keyword, so don't do that. Um, yeah, so for value food. So yeah, this is another way for us to perform a for loop. We can iterate through the elements of a list. And since there are 3 elements in this list, this command executes 3 times. If there were 2 elements, the command would only execute twice. Only execute twice. As you can see here, 2 elements only execute twice. So does anyone have a question? You can type a question here. Someone's hand is raised. Can you just type a question in the chat? So that's how that works. Yeah. So another cool thing we can do really is okay, just a cool thing I want to do. Have a question, just write it in the chat. something there. Sorry. Yeah. All right. So this here is what is called a nested for loop. So here is called a nested for loop. So it's a loop in a loop. And what I wa- also here, what I wanted to do here was, I have a list of foods, I have a list of days. So I'm just to print out, statement telling us what day you had what, essentially. Yeah. So here I iterated through the days, and inside that I iterated through the foods. So notice before I didn't write anything here because I didn't actually want anything to happen underneath here. I actually want anything to happen here, but you can't leave this empty. So actually, I also put something here. So why there was anything to happen here? Okay, so that's because how this works is if when the loop begins, we are on Monday, then this other loop takes over. This other loop takes over. Okay, yes, sorry. This other loop takes over, and it then goes through this list before this other before this other loop then takes over and goes to the next day, and then this now happens. And yes, someone rightly called exactly. Why is Apple egg not given for Monday? And that's for a very simple reason. That is because um for this loop, so now we notice something here. Days is being okay. So okay, as I said, we go into this loop first, it loops through the days. Now, when it loops through the days, we didn't actually store these days. We didn't store the days. That's one thing. We didn't store the days. And also, as I said before, when it goes to a new day, it has finished going through this loop. So by the time so when we go through on Monday, it then goes into this loop. But the value is egg, then the value becomes fish. This print statement is outside this loop. So by the time we print, our value is fish, but our day is Monday. That's the first run. Then the second run of this outer loop, which is when the day is Tuesday, we go in here. At first, the value is egg, then the value becomes fish, then the day is then printed. So that's actually why we have um fish twice, because by the time we print this, the value is fish. So that's why. So it's actually correct that so that's why the apple egg is not given for one day. So if someone says, can we use day in this? We don't use day in this. Okay, that's what you are doing because there's no list called days. So, but actually now I actually okay, so let me see. This one. It's for days. Because I had days created before. If I were to restart the kernel, then that would actually be, you know. But shall that source illustrate the point actually that in a nested loop, by the time you come outside, the inner loop has already finished its run, So that's what it was trying to illustrate. What was trying to illustrate. If time permits, I'll go back and actually try to remedy this, but that's what I was trying to illustrate. So yeah, So now moving on to the while loop. So how a while loop works is essentially this. So notice how a for loop has essentially it runs for a finite amount of time. What if you wanted a loop that could run infinitely, forever? Yeah. And so yeah. So we could use a while for that. Why? Because of how the while loop works. A while loop works by executing a block of code as long as a certain condition is met. So if we create a variable I and equates to zero and say while I is equals to zero, we want to print yeah, what's good? Oh yeah, sorry, exactly. Yeah. Double equals to zero. So so it just goes on and on and on and on. Let me stop this. Let me kill the yeah. And now I'm struggling to kill the program. It's going to run forever essentially. So let me kill. And it's hanging now. Yeah. One of the issues with attempting to do and create an infinite loop. You end up stressing your system if you okay, yeah. So I think I managed to kill it. My system is still trying to catch it. Why let me wait for a bit. Yes, Miriam, I explained why. This was to illustrate something. Why it prints fish instead of eggs is because by the time we get to this print statement, every single time the value is fish. Why? And the stuff is are still hanging. I'm sorry, I'm coming. I might have to close this so that my laptop cannot freeze. Okay, sorry. Coming. Yeah. All right, so I've stopped that. I've killed it. So that's how a while loop works. So let's say if we can also get the while loop to perform for a finite amount of times. How? Okay. And yes, you could actually add a break function to actually stop your loop from happening once it happens. But I'll get to that actually. So now we could also get a while loop to happen just a finite amount of times. How? So let's say we want to print good morning three times or something. So we create I is zero. So while I is less than two, print good morning. And in this block, what do we do? We increment I by one. Okay. And so we have good morning twice. And how does this work? Okay, fine. So I is zero initially. Zero is less than two. It prints good morning. I is then incremented by one. So I has then become one. So by the time the loop gets here, I is less than two. That is true. It prints. I is then incremented. I has become two. Two isn't less than two. And so the while loop stops. So yeah, this is how to make use of the while loop, essentially. So that's pretty much it. And for what we wanted to do here, actually, we could actually is a better approach to carry this out. And what's that? I could create a dictionary actually. Let's call it timetable. Let's call it timetable. Okay. Okay. That's a better approach to do what we want to do. Okay. So, Let's see. So many values in park. Why? Mm, Marcus, let me show you here. Yes, no doesn't change. Expected single adjustment. Get back to this. So looking now, get back. That should have worked. I'm not quite sure why it didn't. Not quite sure why it didn't. Let's. That should have worked. I'm very sure. And this is one of the things, we have an idea. You try it, it doesn't work. You figure out why, you try again. Yeah, but not sure. That should have worked. Try. So, so first thing I want to try. Comments, response. So let's see. Okay, good. So now this worked. All right. So let me explain what actually happened here. Um, and the key lies with this timetable or items. All right. Let me even see. Let's start with statistic items. Yes. So what exactly happened here? Um, so this creates a list of tuples that contains, and each tuple contains a key and a value essentially. So this this is a list as you can see. This dictated whatever is sort of a list. So we can iterate through it. Yeah. And each element of that list comprises of a tuple that contains two parts, a key and a value. So essentially, what we're trying to do here with for k comma v is we're trying to access the key and value in each element of this list. Yeah. So when this iterates the first time, when we iterate through table of items the first time, we are actually here, we're in this element. And in this element, k or our key is Monday and our value is egg. Then the second time we're in this element there's a tuple. And the tuple comprises of Tuesday and fish, where Tuesday is the key, K, and fish is the value V. And so by the time the loop gets here, it then prints on Tuesday I had fish. So that's how this works. I hope are there any questions? You guys understand? So is that understood? So I hope that from it, you guys are going to get an idea of, what is desired on the usefulness of dictionaries and lists and whatnot, and using them in loops and knowing when to use them in loops, and whatnot. So I hope that's understood. No, I'm not getting any responses from you guys. Going back to this, I could probably still make this work somehow. Probably still make this work. Well, if I can, I think if I can by tomorrow, I'll receive this book. We've done it with our dictionary iteration, yes. So that has been done. I hope it's understood. I'm sorry, I don't understand. I don't understand what you are saying, Michael. Could you please explain? With which of the loops? This one? Let's see. Thing is, in the for loop, I did not. There is no I anywhere. There is no I anywhere. I didn't use I before. Yeah, and yeah, this will actually work some more. But then the thing is, it's going to repeat it more than two times. It's not repeating it six times, and you're going to see. So let's actually try suggestion. It's actually not repeating like six times. So let's okay, not six, four times rather, two times six. So yeah, it does the job, but it gives us, and there are still some issues here and there, and it happens four times. How I could tell that I was going to print four times is because this loop iterates twice, this loop iterates twice, two times six, four. So that's how I could tell that it iterates more times than we need it to iterate. Well, that's actually I put that print statement outside and not inside. Because I wanted it to just happen just twice. You know, at least that's what I did the first time before I then changed it, and I'm not sure what happened. So that's what happens when you know. So that's pretty much that with loop. So I hope you understand. Do you understand? Or Michael says he understands. Does everyone else understand? Or have any questions? Before we move on to the next thing. Well, I mean, George, I would like to do that now, but sometimes I want to go through. So I'll look at this later and we'll get back to you tomorrow briefly, hopefully. Um, so let me talk about functions quickly, anyways. So I want to talk about two things, functions and variable scope, essentially. So, um, let's create. Does anyone have any full knowledge of what a function is? So I'll just say what a function is. A function is basically how would I put it? Okay, so yeah, exactly. The group segments together. I think of it as a block of code that does a particular thing, you know. So let's say we want to perform addition. We could create a function for addition and then put all our code related to addition under that function. So that's what it really is, honestly. It's a way of you are reusing or organizing your block of code under a name so that you can just access it whenever you need to access it. So let's create a function called add. And in functions, we have a couple of things that are called arguments. So they are passed into the parentheses of the functions, probably because the function is going to need them to perform some kind of operation. So in this case, we are going to create a function that adds two numbers together. So yeah, we are going to print, yeah, this. Yeah, I did not terminate. Yeah, so that was it. So this is the function definition. Yeah, someone said, yeah, it helps not repeat our code unnecessarily. That's very good. Because instead of having to retype or just copy paste the code you've written for something, you could just call the function name and it will help you perform that task. So yeah, that's very good. Very good, Ahmed. It's very good for organizing your code. It's very good to prevent you from having to repeat your code, when you want to perform that particular task later. So this is a function definition. We use a keyword called def. Give the function a name. Yeah, function a name, and then we write the code underneath. So to actually use this function, we call it. Now, because this function has parameters, for it to work, you actually have to pass in your parameters. So the numbers you want to add where you're going to pass in, and then wait, let's see, didn't I write it properly? Or did I misspell or something? Let's see. So I think I run it's will I change the name of the name. So exactly. So now we've written a function to add numbers together. So that's basically what a function is. This is a function definition, and this is us actually using the function. It's a function call. So if we were not to pass anything through this, we would just get an error because the function requires two arguments and we did not give it any, you know. So yeah, that's that. And you could see that it's set positional arguments, like different types of arguments, not positional and keyword arguments. So with positional arguments, what sort of happens is, okay, the first thing is their values are not predefined. The user determines their values. And the second thing is which variable is assigned which value. It depends on the order in which you write the value of a call. So what I mean by that is X um, in this our code, X1 is 5. Why? Because I wrote 5 first. And X is 10 because I wrote 10 second. So that is why the operational arguments. So for two reasons, the values are not predefined. And second reason, the value they take on depends on which numbers or you write where. I hope you sort of get my point. Yeah. So for example, if I decide to use x to here, x to here, you know, yeah, what happens instead is that our x2 is now 5 and our x1 is 10. So, yeah, their values depend on the position of the user inputs essentially. So that's why. So let's say we want to create a function that multiplies. Okay, let's say we want to write a program that prints out the two times table for the first 12 numbers. Let's create a function that multiplies the number by two. So let's call it the it takes a number. It's, yeah, because you define the function with just two values, it only works for two values. If you try to do with more than, it's not going to work. And less than as well, it's not going to work. We get an error. So if we add a third number, we're going to get an error. It expects two, but three were given. If we try to use only one number, we also get an error. This doesn't work as well because it requires two, but it has only one argument. So yeah, that's to answer your question. So back to the task. So because we define our functions to work with arguments less than or more than our functions of it. Yeah. So this is a function definition. So for I in range zero, as you can see, I've been able to combine our knowledge of loops and functions to print out the two times table. I think up to number 12. So does anyone have any question? Do you guys all understand what I just done? Any questions? Is that understood? Please, a response, anyone? Today? Or there's something else I want to try to show you guys. Exactly. So now this is something I wanted to tell you guys. When you have a keyword and positional argument, your positional argument should always come first. Should always come before your keyword argument. They're always. So as you can see here, non-default follows defaults, blah blah blah. So when defining a function, if you have arguments that are keyword and positional, write the positional ones first before writing your keyword arguments. That's pretty much that speed. Yeah. So that's write your keyword before you write your question or rather before your keyword. Remember, keyword arguments are arguments that you define, that you give a value in your function definition. As you can see here, we give y a value when defining our function. And because we did so, when calling our function, we did not have to put y in the parentheses like we did here, where we had to supply two values, because only one value was needed from us. So we only put that single value in here. So yeah, that's that. So in the absence, if there are any questions regarding anything I've done today, ask. So I'll give you guys like 2, 3 minutes to ask any questions about anything I've done today. And after that, we end the class for today.
Great, 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 great. I can see a lot of thank you in the chat. Thank you so much, Mr. Iwezu. This is another awesome delivery. Yes, I'm very sure you all agree with me that it's been a learning today. Yeah, it's been an intensive one. Thank you so much, Mr. Iwezu. Please confirm you can hear me in the chat. Jeremiah is saying thank you. Thank you. Yeah, it's been 2 hours of intensive learning. Bigs of Mr. Iwezu. So George is saying bigs of Mr. Iwezu. Thank you so much. Okay, Oluwadim Nadi is confirming that he or she can hear me. Jeremiah, we can hear you. George, we can hear you. Thank you so much, everyone. It's been an awesome 2 hours. Like I told you that this is going to be another awesome delivery, and you will agree with me that this is it. So the conversation continues on the Telegram group, and this is just day two. We have five. We are going. This is going to be running for 5 days, so this is just day two. And from tomorrow, we are now going to be doing more of machine learning. We are going to be learning the exploratory data analysis part of this course, which is how to use pandas and numpy. What we've just been doing is to introduce guys to Python very quickly. And I'm repeating the word very quickly because you are taking a lot in a very short while. And let me even give you a brief about Python programming. So when you are talking about Python programming, we can say it is categorized into, should we say, 3 or 4 parts. We have what we call the Python data types. We have what we call the Python data structure, and then we have what we call the Python control structure, and then we have what we call they are not really under a category. We have what we call class, object, polymorphism, abstraction, and all those ones, map, reduce. So we can say Python is actually categorized into 4 parts. You learned about the Python data type yesterday when we talk about strings, boolean, complex number, floats, and integers. And then when you are talking about Python data structure, this is how your data be structured. So we talk about the list, we talk about the tuples, we talk about the set, and we talk about dictionary. And then the Python control structure speaks to how you can make your code flow basically. And that's where we talk about loops, and then you talk about functions, how you can make use of you can iterate your code, or when we are talking about function, you can make use of repetitive codes instead of writing many codes. You can just create a simple function that will keep calling that particular line of code you are using. So this is the whole overview of Python programming, and that's what we'll try to do in just 2 days. So which means that you need to actually go back again, watch this recording once we are done with the session so that you can have in-depth knowledge. So, like we do say, there are also resources online on YouTube, on Google to help us out. Yeah. And then we also we've shared the self-paced link with everyone via mail. I mean during the weekend, yeah, we've shared that. So you can also go click on that link and start learning also at your own pace, even while you are having these virtual classes. So what I'm trying to say is there's a lot to learn. There's a lot to learn, but in those 5 days, you can rest assured that you will cover everything you need to start a career as a data scientist. Yes, I can assure you of that. So thank you so much, Mr. Iwizu, again. Thank you so much, everyone, for joining this today, this afternoon. So we're going to be rounding up now, and we'll continue from here tomorrow. Like I said, the conversation continues on the Telegram group. If there is any question, we have our dedicated support. Chidima is on the group. Tawezo is on the group to answer all your questions. Yeah, yeah. So that will be all for today. Thank you so much, everyone. Do enjoy the rest of your day. See you tomorrow, and bye bye for now.